All right, this is the Algebra 1, Unit 2, Lesson 6 video. This is the last lesson from our unit for Unit 2. So then next week you will be doing review and testing. So this main kind of concept in this lesson is about ratios, proportions, and then the idea of percentage as a type of ratio. So kind of talk about some terminology first. A ratio is another word for a relationship between two numbers. So a ratio can be really any kind of fraction. Sometimes you'll see it written like this. Sometimes you'll see it written out 3 to 5. These are all different ways of writing the same ratio. So again, a ratio is just a relationship between two numbers. And then a proportion is going to be when we actually try to make comparisons between ratios, and we find that they are equal. So for instance, 2/3 is equal to 4/6. And that's because these two fractions represent the same value. If you were to type these into the calculator, both would give you the answer of 0.66 repeating. So we know that's the same value. So proportion is a comparison or equivalence of two ratios. So a ratio compares two numbers, and a proportion is saying that two relationships like that are equal to each other. So in this unit, you're basically going to be using ratios to solve problems. And the real main thing that you need to understand is that there is a way to make these proportions not fractions. And that's helpful in a lot of ways. One is that it helps you to just make it easier to deal with, but also it helps us when we need to solve. So just as an example, without getting into too much detail, we know that if I multiply those two numbers and I multiply those two numbers and I look at the answers to those are going to be equal. 2 times 6 and 3 times 4 is 12 and 12. This idea is called the means extremes property of proportions. The means extremes property of proportions. And it basically is known, you probably heard it called another name, which is cross multiplication. And so this method of multiplying the diagonals, like you see here, is the main method we're going to use when we're trying to solve proportions. So the means extremes property means that if I multiply the diagonal values in my proportion, the answers to those are going to be equal. So let's look at what this actually looks like in practice. Usually it's going to be used when you have something like this. 1 over x equals 8 over 40. Okay, so the reason this property is useful is right now I don't know what x is in this proportion. But using the means extreme property, if I take these two values and multiply them, and I take these two values and multiply them, and say they are equal to each other, so 1 times 40 equals 8 times x. So I get 40 equals 8x. And then I solve that using the stuff we learned in the last lesson. Remember, to solve an equation where you have 8 times x, we're going to divide both sides by 8. Those are going to cancel out, leaving me with x equals 40 divided by 8. You can use your calculator if you need to, but the answer you get is 5. And so this ratio, written out completely, is that 1 over 5 equals 8 over 40 because x equals 5. And so we're going to be solving equations like the one you see here that are ratios equal to each other, a proportion, and we're going to solve those proportions using this cross multiplication method. So let's look at some more examples. They give an example in the unit, and I'll use their example, and they give us these two rectangles. And they say, okay, in these two rectangles, this has a length of 5 inches and 4 inches here. And then this is 12 inches. And they want to know what's the value of x. So this is a great example of how you can use proportions to solve problems in geometry. Because if we know that this is the length and this is the width, and this is also the length and the width, then I can make a proportion out of these two sets of values. In other words, each set of length and width can be written as a fraction. 5 over 4, length over width, is equal to length 12 over x. That's our unknown. So you see here we have the small rectangle. Here we have the large rectangle. We have the length going across the top of each fraction, and we have the width going across the bottom of each fraction. Using what we learned about cross multiplication, if I multiply these and I multiply these, 5 times x is 5x equals 12 times 4. 5x equals 48 divided by 5. I'll do that in a different color. Divided by 5, divided by 5. X equals, and if you do that in your calculator, you get 9.6. I just would do 48 divided by 5, and I get 9.6. That is the length of this. So again, another example of how we set up proportions. Now, I'm going to walk you through how to set up proportions in your problems in your unit, but really what you need to understand is that everything has to be lined up. Each fraction needs to be one of the two things you're looking at. Here it was the large rectangle and the small rectangle. And then each top or bottom of the fraction needs to refer to the same thing. In both cases, the top of the fraction referred to the length, and the bottom represented the width. So that's kind of how I want you to think about it when you're setting these up. So let's jump over to our lesson and let's see what they have for us. Okay, we have some vocabulary in number 1 and in number 2. Remember, these are called the means and extremes, A and D. I'll just tell you about this one. It's also written up here in your lesson, in this diagram right here. You can see here that the extremes are the A and the D term, and the means are the B and C term. So you need to look at that for your answer to number 2. We have the extremes and we have the means. So then we get this problem. Ben is 6 feet tall. He pounds a stake into the ground until only 1 foot of it is remaining out of the ground. Its shadow is 6 inches long. How long is Ben's shadow in feet? Okay, so let's draw a picture. We have Ben. Draw our guy Ben here. He's 6 feet tall. That's how tall he is this way. Then we have a stake in the ground. The stake is 1 foot tall. Erase this. Let me draw this again. I have a stake in the ground. And it is 1 foot tall. And it says the shadow of the stake is 6 inches long. How long is Ben's shadow? So we have the height of the object, and we have the length of the shadow. So let me draw the length of the shadow in another color. So there's a shadow here, and the shadow is 6 inches, also known as 1/2 of a foot, 0.5 feet. And then Ben has a shadow as well. And we want to know how long is Ben's shadow. So you can see, even in drawing a picture the way I did, I'm showing you how to set up this problem. We know that Ben is 6 feet tall, but we want to know his shadow's height. We know that the stake was 1 foot tall, and that the shadow of the stake was 0.5 feet tall. Notice we have the height of the object and we have the height of the shadow. I should maybe just say we have the thing and we have the shadow, right? So these are the shadows down here, and the things up on the top are the length of, or the height of, the actual object. So we use the means extremes property, also known as cross multiplying. We do 6 times 0.5 equals 1 times x. And so we get 1x equals 3. Because 6 times 0.5 is 3. 6 times 1/2 is 3. And so then x equals 3. So I've gone ahead and shown you the solution to that problem. But again, I want you to see we have Ben in one fraction. We have the stake in the other fraction. We have the height lined up across the top. We have the length of the shadow lined up across the bottom. So once we line everything up, it's just a matter of cross multiplying and then solving for the x. All right. Same here. The ratio of boys to girls is 2 to 5. That's 2 over 5. And there are 40 boys. Make sure you line up boys with boys, girls with girls. All right. So looking at the next one, we have ratio of boys to girls. We have boys and girls, 2 and 5. That's what it says right here. And then it says there are 40 boys. 40 boys. Again, boys is across the top here. How many girls are there? So I've gone ahead and set that one up for you. So you should be able to cross multiply and solve the rest of that one. Remember, multiply those values. All right. Then we get to a percent problem. So I'm going to pause on this and, sorry about that, and talk about percents over here on my Google Keep. So percents are a special kind of ratio. Percent is a ratio in which the denominator is always 100. You've heard of the idea of having 100%, right? Well, 100% is the kind of whole part that we're always comparing something to. So if we have 34%, we mean 34 out of 100. If we have 12%, we mean 12 out of 100. So this idea of a percent being a ratio out of 100 is kind of the key idea of this part of the lesson. So if they ask me, for instance, what is 24% of 300? Let's talk about how I would set this up. Well, anytime you have the percent already in front of you, you automatically know that that is going to be this fraction, 24 out of 100. So any percent can be written as that fraction. And then the other half of my proportion is going to be this idea of 100. So we need to decide, is 300 the total amount or is 300 the part? And since it's clear from here, what is 24% of 300? Just common sense, 300 is the total amount. So then the thing we're looking for is this x right here. So we jump over here and we do cross multiplication. We're going to do these times each other. That's 24 times 300 equals 100x. 24 times 300. Go ahead and go open a Desmos scientific calculator and do 24 times 300. 24 times, let's close this, here we go, 4 times 300. And there it is right there, 7,200. Drawing over here. That's 7,200 equals 100x. Then we divide by that number there. Divide by 100. Divide by 100. That cancels out. Don't need to do that twice, but you get the idea. That cancels out. And we get x equals, and that's 100. Sorry about that. That's going to cancel out two of those zeros, leaving me with 72. And you could also do 7,200 divided by 100 on your calculator. 7,200 divided by 100. And we get, oh, my bad. Let's go back there. Where's my division here? Divided by, nope. There it is, divided by 200. 100. Sorry about that. 72. And that's where we're getting that from. So that's where you get 72. So it would be 72 out of 300. So jumping back over to my lesson, we see that's basically what we have in number 5. It says, what percent of 300 is 67? So what percent means x over 100? What percent means we don't know the percent, so that's the x, is 67 out of 300. And so there we are, we're set up to do our cross multiplication. All right, if a train travels 420 miles in 24 hours, what is the unit rate of travel? This is actually even more simple than the ones we've been doing because this is a simple ratio problem. They want to know miles per hour. So that can be written as miles per hour, which is what you see on your car, or miles divided by hours. And so you need to do the number of miles divided by the number of hours, and the answer you get should be one of your answer choices here. Lastly, or not lastly, but next, if there are 22.54 centimeters in 1 inch, how long is a 36-inch long measuring stick in centimeters? Again, this shouldn't take too much thought. You know that 1 inch has this many centimeters. So what if you did times 36 of that? In other words, that's what we're doing. We're doing times 36 inches. So you need to multiply the centimeters times 36 to find out how many centimeters there are in a 36-inch long measuring stick. More of the same. So this is another ratio, a proportion rather. It says here, the rate of exchange here for converting your pesos is that for $5, there is 115.21 pesos. So how much would she get for 1,047.5 pesos? We don't know. How many dollars would she have? X. So we know we're going to do cross multiply, and divide, just like we've been doing up above. Again, similar. He has a painting. It has a width and a length, or a height. I guess it says tall, but you get the idea. Let's say it has width and how tall it is. Well, it says he reduced the side of painting to a width of 33.2 inches, 3.2. What would the new height be? We don't know. If the painting was originally 42.88 and 33.5. So then the last thing you need to do is cross, multiply, and divide. So I've kind of given you a start on all these problems. So make sure you're doing those. Follow along with my work and my suggestions on those. And besides that, I think you'll be good. And the next thing you'll get from me will be a review.